Welcome back everybody to another video lecture from Miss Semino. This video is for 6.2. This is the second set of notes on the periodic table. The objectives for this video lesson include describing the information on a periodic table, classifying elements based on their electron configuration. Now remember, electron configuration is where we describe the location of electrons using 1s2, 2s2, 2p6, and so on, and then distinguish between representative elements and transition metals. The first thing that I want you to do on your notes is to copy down this box from the periodic table for sodium, and then to include all of these other items that the periodic table describes. Go ahead and hit pause on your video if you need to at this time. Now notice that some of the things we've already talked about in class. We have atomic number. That was our number of protons. We have the electrons in different energy levels. So we don't have this on our periodic table, but we might see it on others. So 2 in the first, 8 in the second energy level, 1 in that last energy level if you're remembering how to write the electron configuration. Of course, the symbol, the name, and the average atomic mass. On other periodic tables that we might get later this year, we might see other things like melting point, boiling point, and even some actual electron configurations. Now, one of the big things I want you guys to get out of this lecture is to be able to identify the location on the periodic table about different groups of elements, and then to know the properties of those elements. Of those groups of elements. So the first group that I want to talk about is the group 1A. This is the first column on your periodic table. We talked about them a little bit in the last video. They're the alkali metals. And the characteristic that you need to know about these is that they form a base when reacting with water. So anytime you put, like for example, potassium, which has a symbol K, it's an alkali metal. With water, it's going to form potassium hydroxide, which is a base. Now, group 2, these are referred to as the alkaline earth metals. These also form a base with water. They don't dissolve as well, so sometimes they're called earth metals, and they're not as reactive as the alkali metals. Another group that you need to know is the halogens. These are the second to the last column on the periodic table, and this means salt-forming. Now, one of the very helpful things that we're going to be doing in this unit is we're going to be able to look at an element's electron configuration and be able to find their location quickly and easily on the periodic table. Beyond being able to find it on the periodic table, we're going to go ahead and be placing it either as a noble gas, representative element, transition metal, or an inner transition metal. Now, the characteristics of noble gases that I want you to know is that they were previously called inert gases because they rarely take part in a reaction. So they're very, very stable, and so they usually do not react. And so what you should know about their electron configuration is that noble gases have an electron configuration that has the outer s and p sublevels completely full. So they'll definitely have 8 electrons in their Lewis dot structure. The next group of elements that I want you to know about are called the representative elements. These can be found in 1A through 7A. And they're called representative elements because they represent a wide range of properties that elements have. So some of our representative elements are going to be metals, nonmetals, and metalloids. Some will be solids, gases, and others liquids. So what we need to know about this is that their outer s and p electron configurations are not always filled. Now, another group that we need to know about are the transition metals. They're located in the B columns of the periodic tables. So like on the fancier periodic table you'll get later, you'll see that there's A and there's B groups. The electron configuration has the outer S sublevel full and is now filling the D sublevel. I don't know if you remember, but from our orbital filling diagram, we would often go 3p to 4s and then go back to 3d and fill it up. So that's what they're saying, is that the S is full, then you'll go to the D sublevel. And so we considered a transition between the metal area and the non-metal area on the periodic table. If you look on your periodic table, you should hopefully see like a big black staircase line. We generally say that things over here are metals and things over here are non-metals, and so we find the transition elements in this little area right here. It kind of goes, it dips down here. And so this is where we find those transition metals. And some examples of transition metals are gold, copper, and silver. Another group that you need to know about are called the inner transition metals. These are located below the main body of the periodic table. So on the last few slides, we talked about the properties of different groups, and so now we're going to see where those groups are on the periodic table. So if you look at the ones that are circled here, the elements in the 1A through 7A are called those representative elements, okay? And they have S and P orbitals filling. This middle section here is called the transition elements. And then if you look down here, these are those two rows that I was talking about, those inner transition elements. And one of the POGLs that we're going to see this week, we're going to see how these two rows actually should be placed up here. So the periodic table should actually be a lot longer than it actually is, but we've just kind of pulled these elements out below here. So again, a quick refresher, this group right here is called the alkali metals. This group right here is called the alkali earth metals. The halogens are over here, and then the noble gases are this last column. Now take a second and look at the elements listed here. We have hydrogen, lithium, sodium, potassium, and so on. I'm hoping that you're noticing that this is the first column on the periodic table, and again, these are referred to as the alkali metals. Now we also have the electron configurations for each of the elements listed here, so take a quick second and see what you notice about all of the electron configurations here. Hopefully you're noticing that they all end in S1, and that's because the first two columns on the periodic table are referred to as the S block, and since they appear in the first column of the S block, that's why we're going to call them S1. Now on this slide, let's go ahead and do the same thing. Let's look at the elements that they have listed here: helium, neon, argon, krypton, and so on. And I want you to go ahead and look at their electron configurations and see what they have in common. Go ahead and pause the video if you need to. Now hopefully you're noticing is that their outer shell is full. So what do I mean by that? Well, helium only has one shell, so its shell is full because the first shell only holds 2 electrons. Here we can see that we have 8 electrons here, so we know that this also has a full valence shell. Again, we have 8, 8, 8, and then 8. We'll go ahead and we'll talk about how these D sublevels are tucked underneath the P sublevels a little bit later. So 2 slides ago, I referred to these as the S block, the first 2 columns. So again, any element in this column is going to end in S1. Any element in this column is going to go ahead and end in S2. Now the middle section of the periodic table is where the transition metals are, is referred to as the D block. So if you were to look at the electron configuration for scandium, you would see that it ends in D1. If you'd look at the electron configuration for titanium, you'd see that it ends in D2. We did vanadium several times on our worksheet. It ended in D3, and so on. Now the P block is found on the right-hand side of the periodic table, and I've just inserted some of the elements that you'd find here. So there'd be boron, carbon, nitrogen, oxygen, fluorine, neon over here. And so what we're saying is if we had an electron configuration for boron, we know that it's going to end in P1. So let's go ahead and look at an example. Boron has 5 electrons, so the electron configuration for this one would be 1s2, oops, that's a 2 there, 2s2, then 2p1. Notice we have the 5 electrons here for boron, and it ends in 2p1, just like we said it would. Now if we look at oxygen over here, let's see if it really does end in p4. So we'd have an electron configuration of 1s2, 2s2, there's 4 electrons, we need 4 more, so it'd be 2p4. So again, notice how oxygen is ending in p4, and it's in the p4 column. Now the inner transitions, remember, at the bottom of the periodic table in those rows, and again they're called the F block. So if you were to start at the beginning of the F block, you'd know that this element ends in an electron configuration of F1, this one ends in F2, F3, F4, F5, and the same of course for the second row. This one will end in F1, F2, F3, F4, and F5, and then so on, as you can see from the column numbers. Now I think we might have mentioned this in the last video, but the periods are numbered. So period 1, period 2, period 3, and so on. What you hopefully notice is that when we're talking about hydrogen up here, when we write its electron configuration, we're going to write it as 1s1, meaning that it's in the first energy level. Sodium down here, it has those 11 electrons, so its electron configuration would be 1s2, 2s2, 2p6, and then 3 S1. So the highest energy level is 3, meaning that sodium has 3 shells or 3 energy levels. Figuring out the energy level associated with an S and a P block is pretty self-explanatory. If we're in the 4th energy level here, this is going to be 4S. But remember, after we fill the 4S, we have to go back and we have to fill the 3D. So we like to say that you're going to take your energy level, which is 4, minus 1, and then that will give you the energy level for your D sublevel. Now on the last slide, remember we said that to figure out the D energy level, we would take the energy level and we would subtract just 1. For the F energy level, we're going to have to go ahead and subtract 2. So remember that this column right here should be like inserted up here. So it's really in the 6th period. But like I said, you're going to go take your energy level minus 2, and then you'll find out that you'll be in the 4th F row. Or you can do the same thing. This one would be inserted here, so it would go 7 minus 2, and that is going to give us 5F. So the last electron configuration for this one is going to be 5F down here. Remember, it'll be 5F1, 5F2, 5F3, 5F4, and so on. From this video, I'm hoping that you learned a little bit more about the groups and the properties associated with them and where they appear on the periodic table. The other big takeaway, again, is to be able to talk about the different parts of the periodic table. So don't forget, this is referred to as the S block, the first 2 columns over here, and this holds your alkali metals and alkali earth metals. This middle part here is your transition elements, and they are considered the D block. Elements over here, for the most part, are representative elements. You do have the noble gases, which are also part of the P block. And then you have your inner transition metals, which are referred to as the F block down here. I hope this video was helpful, and I'll see you in class.